Hello, Mr. Gazda here. Homework 94, Igneous Rock Coloring. Here we go. This sheet contains the Igneous Rock chart from the reference tables. It's on page 6. Color as directed. Please, the goal here is you know it. There will be a quiz on it. Know this stuff. It's not about just coloring. It's not about writing answers on a line. It's about you knowing igneous rocks, being able to identify them, and use the chart. So, some keywords you're going to be interested in knowing. Let me get this. Where is it? There. Okay. So, here we go. Know it. Igneous rock forms when molten rock cools and solidifies. Okay, molten rock is liquid rock. If this happens on Earth's surface, the rocks are classified as volcanic or extrusive. Okay, on the surface. If it occurs underground, the cooling, solidifying, it is called intrusive or plutonic. And this is where they're located here. These rocks, all of these rocks here, are considered the extrusive or volcanic rocks, and all these rocks here are intrusive, which means they formed underground, they cooled from a liquid underground. So it says color the box on the table that says extrusive volcanic yellow. Here we go. I have my colored pencils. Here we go. So what am I doing? Extrusive volcanic. I'm coloring the box. I'm coloring that right there. That's extrusive. All of these are extrusive volcanic. 3. Which of these rocks is extrusive or volcanic? This is based solely on the reference table. Granite, gabbro, scoria. So you can look here. Granite is actually an intrusive rock. The next one is gabbro, also intrusive rock. Scoria is here, extrusive. Answer to that one is going to be scoria. Here's an example of scoria right here, and I want to show you the real rocks. We'll talk more about this in the future, in just a little bit, actually, on the back side of this page. Next one. 4. Know it. The slower the molten rock takes to cool and solidify, the larger the mineral crystals will be. Slower, larger. That is key. Know that fact. Know it. So here we go. By large, we mean anything you could see with your naked eye. So here is an example right here. Okay, this is an igneous rock right here, and we're going to call this to be like pretty large crystals, coarse texture, because you can see the black ones there. The black ones really do stand out. Okay, I could see that crystal right there with my naked eye. I could see them. The white ones and gray ones are a little harder to distinguish, but this is going to be considered coarse texture. Okay, and that's actually a very large one there. But okay, that's one example. But we're doing larger crystals, so we know this cooled slow underground. Here's another good example. This rock is a piece of a countertop. It's been cut and polished, so you really can see the crystals really well, and there's a reflection of the light right there. Let's try to get rid of the reflection of the light. So you can see, here's crystals here. This is our angular interlocking pattern. We can see the pink potassium feldspar. The white is generally plagioclase feldspar. The clearer one here is going to be quartz, and the black is mainly hornblende with some biotite mica in there. Large crystals, look how large that is right there. Here, that. All of these I can see with my naked eye. Coarse crystals, intrusive, formed underground. Took a long time to cool, many years, hundreds of years, even into thousands of years. So this cooled deep underground, and I love this example because it's very dramatic, and you see really large crystals here. I really like it. Here we go. Let me block that out if I can. Okay, and if you see, I don't want to block that out. Here we go, because it's very, see this crystal right here, and this one right here. You see how like the angles of it. Really, this is a huge crystal. This one here, and you see the angular nature interlocking. These other minerals all interlocking between it, and it's all randomly placed. You can see them here. This is a great example of very large crystals. This must have taken a really long time to cool. Therefore, that happens deep underground. Where the heat sort of can't really escape, basically, or it's not touching cool air. Really cool example on the edge here. I don't know how well this is going to be shown. The light's kind of weird on it, but this is what it would look like normally without being polished. And that's the. Ooh, wait. How about right here? So this is what that rock may look like more naturally when you find it. A little harder to see the angular interlocking, but So this is the idea. Cooler, longer it takes to cool, larger crystals will be. If it has no visible crystals, like, let me go get this one, like maybe something like this, like that. Here you can't see the crystals really. They're really fine. This cooled slower. This is more of like from a lava flow. Took days, hours, days to cool, and the crystals are very small. They didn't have that chance to continue to grow over a long period of time. So that's what we mean by 4. Question 5. Rocks with coarse texture have crystals between the size of these lines. That size and that size. Okay? So this is definitely something that has a coarse texture. These minerals are larger than that line, not as big as that. This would probably fall into the very coarse texture because this is so large. And then this would probably be a good example of coarse texture here because this is probably between the size of those lines right here. Okay? Now on the reference table, where does it show those rocks? Color over the names of all the coarse textured rocks with blue. So this is coarse texture. Okay, so it's going to be this one, this one, this one, this one, and this one. What am I doing? Blue? Here we go, blue. Blue, and I'm just going to color over the names. I can just do this. I can color the whole boxes. It doesn't really matter. It's this right here. I'll color all the boxes. That's fine with blue. Just to get a sense that this is all the coarse ones here. Okay, and that's 1 millimeter about to 10 millimeters, which is 1 centimeter. That's where that comes from. Back side, I have the chart again. Look at 6. Know it. When lava cools quickly, gases in the lava may get trapped as the lava cools. When it becomes rock, it will have small holes from these trapped gas pockets. It often looks like an everyday kitchen sponge. This is called vesicular texture. These little holes, the sponge like vesicular texture. Okay? And before we go into coloring, here are some examples of vesicular texture. This one again. This little hole, these are gas pockets. They kind of get like it freezes. We can use that word, but it solidifies so quickly the gas doesn't have a chance to escape because the lava is really thick, and it gets these holes in there. This is a really good example of it. That's one example of it. Here is another good example where you can see. This may be a little hard to see actually with the light reflecting off it with the holes in there. The vesicular texture again. This one maybe. Ooh, can you see it right there? All those little they're called gas pockets, vesicular texture, very much like a sponge. You may know that some of these rocks, if it's really low density, can float. This one is particularly low density. And here's another one. This is from Crater Lake, Oregon. I collected this summer when I was there, which is really cool. So there's so many little holes in there. Vesicular texture. The holes are vesicular texture from trapped gases. I do want to point out too, this right here, they're kind of similar, though this is different type of, has different minerals. It's darker, and this is lighter in color. So what minerals make it up is going to affect the what that rock looks like. We often go by color based on the minerals. So for instance, this here has a lot of light colored minerals. Pink, white, clear, very little dark minerals, and that's going to be called more felsic when it's lighter in color. It's also very felsic, a lot of light. There's some black in there. Maybe it's a little more in the middle of the chart. Okay. So color over the names of rocks with vesicular texture with green. Green, I'll color over the names. Vesicular texture, where do you see it? Vesicular are these. So vesicular is all the rocks that are in this area right here. Okay, so is pumice, vesicular rhyolite, vesicular andesite, scoria, vesicular basalt. Those are all vesicular texture, those right there. Please find your locker number on this sheet and find the 2 letters that go along with it. Write those 2 letters on the front next to your name, please. Okay. 7. Know it. Fast cooling lava can also have a glassy texture. If it cools real quickly, it doesn't have a chance for any minerals to form at all, any crystals of minerals to form. So the texture is glassy. And glassy is very cool. People like volcanic glass. Here's probably the best piece that I have. Okay. It's called obsidian, and you can see it is volcanic glass. and is very much like glass. Native Americans would make it would break in a certain way, and Native Americans would commonly make arrowheads out of it and cutting tools because it breaks in a certain way. But very cool. Again, this cools very quickly. No mineral crystals can form. Glassy texture. We're coloring over the glassy texture ones with the color red. Here we go. Red. Red. Where does it say glassy? Glassy. Okay? So this is scoria again, pumice again, obsidian, basaltic glass. So you have pumice can be glassy and vesicular at the same time, which is the same scoria as well, because they overlap there. So that's unique. 8. Between the two charts, find where it says composition. Where's that? Composition is right here between the two charts. Composition. According to the chart, what is the name given to rocks that are rich in aluminum and silicon? Well, if it goes towards this side, it's felsic, rich in silicon and aluminum. The ones over here are more mafic, rich in iron and magnesium. Therefore, what's the name given? It would be felsic. Okay. Now, and this goes by color. These are composition felsic. They're lighter in color. These are darker in color, and the ones in the middle are sort of in between. So this would be a more felsic because it's lighter in color. This would be more mafic because it's kind of made of darker minerals. This one here, huge crystals here, really coarse texture. These crystals are just huge. I don't know how well you can see it in this picture, but mainly light color. There's some dark in there, but mainly light. This would be more in the felsic realm. This would be more on the mafic. It's darker color. Okay? So just to give you an idea, we'll learn more about that. Rocks that are rich in iron and magnesium are called mafic. Color over the word mafic with blue. Okay, mafic is key. Iron and aluminum, the darker color, and what am I doing? Coloring over it with blue. Just the word mafic, just like that. Just to see that it's on that chart and where it is. Color over the names of all fine textured rocks with yellow. So here we go. Fine textured are these right here. And again, I'm coloring over that because these right here are also yellow, rhyolite, andesite, basalt, maybe diabase is kind of in between. You could do diabase or not because it's kind of in between. And again, fine grain would be this. Can't see the mineral crystals at all. Not really too much to look at. Not super exciting, but that's what fine. It cooled fairly quickly. Again, days to weeks. On what page of the reference table is what that should say? Can this chart be found? Search for it. I'll let you do that. But I did want to show you these rocks here. The chart, the rocks are what's cool. The chart is not cool. The chart just helps us with the rocks. So go back, rewatch this if you need to. We'll have a quiz on it, on the basics. So there's not a lot of know it things here. Not a lot on here in general, but know those things, and you do well on the quiz. And you will know it for when you really learn about igneous rocks, and that is the point. Mr. Gazda, signing off. Thank you.